Okay, so we're going to look at the question of arrays and pointers. So in class, we looked at the following kinds of things. We said, I make the declaration, I say int a, have an array called a, and say it's of size 3, and I initialize a to 10 and 20 and 30. Right, there's the example we saw in class, and the diagram we drew was something like this. Here is the array a, and this was a sub 0, a sub 1, a sub 2. There was a 10 over here, a 20 over here, a 30 over there. And we said these live at actual locations in memory. We call this location 100 with a little a. This is 101, a, 102, a. And since each one of these elements stores an integer, right? This stores the integer 10 and 20 and 30. We said, well, this address was 100, and the next one was 101. So it moves up in steps of 1, and this was 102. Right? In fact, that's not the way the actual computer works. Since every integer takes up, as we saw, 4 bytes in the memory, the actual addressing is done on byte level addressing. So if the starting byte here was somehow on a count of 100, then this would be 100, this would be 101, this would be 102, and 103. And the start over here would not be 101, but would really be, in a real computer, it would be a count of 104, because the count goes, as I just said, it goes in terms of bytes. So if we take a look at the this program over here, I have the array A that we just looked at. Here's my array A, and it has 10, 20, and 30. And then what I do in the output statement, I'm basically outputting the address of a sub 0, a sub 1, and a sub 2. I'm not dereferencing it, right? I'm just outputting the address. So what happens when I run this program? So let me just compile it and run it. It's compiling, and it seems to compile and run. So let's check the output over here. So this tells me, first of all, notice the hexadecimal number. You've gone over this in the lab, I hope. So the 0x tells you it's a hexadecimal number. There are 32 bits. Every hexadecimal number represents 4 bits, so there really should be 8 hexadecimal numbers here. Here we have 1, 2, 3, 4, 5, 6. That's because the first 2 positions in this particular run are zeros, and this particular compiler doesn't show it. So it's really 0, 0 in this case, 2, 2, FF, 3, 0. What we did in this program is the first thing, we simply say a plus I. So the first thing is a plus 0, a plus 1, a plus 2. So if if a in the array, the actual start address of the array is 30, then 4 bytes away is 34. So that's where a sub 1 would be, and 4 bytes after that would be 38. That's why you see these numbers, and it was equivalent in the example that you actually ran for homework.